Good morning. Thank you for joining me here for my discussion of LinacView. It's 9 o'clock. I'm going to give the rest of our audience a little time to hook up and join us. I'll be starting approximately 9:02. One thing I might mention is that as with all of our webinars, we've applied for campus credits. Each webinar can get you half a credit. The webinars are approximately 30 minutes apiece, and it's a kind of a nice way to learn about a product and get some credits and learn some technical things as well. And I highly recommend you do it. The way that it works is that you will listen to the webinar, and we get your name from your registration and your email contact, and we'll send you some questions, 5 questions, very much like the questions that you would get if you're going to do an AAPM online webinar class. It's very nice, very easy, and I highly recommend you doing it. There's no reason not to, for sure. So as I said, I'm going to wait till 9:02 to begin in earnest. And there we go. So as I mentioned, my name is Mark Wiesmeyer. I'm the product manager for LinacView. It's a really, really unusual and interesting program. What it does is it compares in real time your RT plans to your log files. It does this in a continuous way. It's patient-oriented, and it's basically Linac QA on a patient-by-patient basis. It's very much behind the scenes and has essentially no impact on your clinical workflow. So as I said, their log files are compared against RT plans instantly and automatically as treatments occur. LinacView can be used for essentially 2 different things at this point. That we have other plans for it in the future. Pre-treatment QA, just like you might use your like a DoseView 3D system, or not DoseView, Mobius 3D, or a map check or something of that sort. You can use LinacView for that as well. You can also do during treatment QA, as I said, and you'll get a flavor of how this works during the presentation, but basically you can do your QA before, QA during, keep track of it on a patient-by-patient, treatment-by-treatment, and essentially you have a complete record for every treatment of the finest details of your delivery. Supports Variant and Electa log files. Variant would be your down logs and your trajectories, and Electa would be at this point through the ICOM-VX interface. We are looking at other ways of doing the Electa, which are higher resolution, the system tests just about every log file parameter. And I'll give you an idea what those parameters are shortly. But there's a lot of things you can test, and a lot of things that might be of interest to a physicist trying to make sure that deliveries are done correctly and that your machines are working properly. It notifies in real time for machine alerts and errors, and that essentially is by email, and you can set it up with a large amount of customizability in terms of who gets emails and what kind of things are alerts and errors and things of that sort. It creates reports that summarize your delivery and your RT plan, and basically it also creates a RT plan that summarizes a treatment series. So for instance, if you have missing fractions or fractions that were not delivered completely, the system will keep track of that and create an RT plan that will account for the missing dose. And oftentimes we know, of course, that that happens in our clinics, and we go to our physician and say, hey, what do you think about this? And the decisions are often made with little or no actual objective evidence. In this case, you can take your RT plan that you summarize your treatment up to date and put it back in your treatment planning system and seeing how that affects your doses. So, so it's a really useful tool. Let's see. Okay, so I had mentioned log files, and many folks have seen what log files look like. This is actually a trajectory file, which is, many of you know, is a binary file, but it's been converted into an Excel file. We basically read the file, the trajectory file, and converted it in Excel for purposes of showing folks what's in the file. You know that Dynalog files are CSV files essentially, and you can just read them directly. But this is interesting. So you can see the basically in blue, you can see collimator rotation, gantry rotation. You can see the next columns are jaw positions, table positions come next, monitor units, whether there's a beam hold or not. And actually very interesting is the control points there. The true beam files have fractional control points in them. And then you can see the carriage positions, and then following that, this is a 120 leaf machine, and you can see expected versus actual positions. With a program like PIPS Pro, we compare the expected with the actual to see kind of like the machine intended to do, but the machine intended to do this, and this is actually what happened. With a program like LinacView, what you're actually doing is you're saying, my RT plan said I should do this, and my actual leaf, for instance, did that go to where it was supposed to be on a control point by control point basis? So there's a lot of things in here that you can compare, and in addition, you'll see that you can actually create fluence maps based on control points and compare those fluence maps to those created by log file records, and each of these is, of course, a record. The sampling speed for each of these records is something on the order of 50 milliseconds, or faster. Okay, so it's kind of a complicated drawing, but essentially it shows the image workflow that happens. So we create an RT plan. Typically that RT plan without LinacView would go directly to the treatment console and or the RNV system, and you basically do your treatment. When LinacView is in the loop, what we do, we do some additional steps. We not only send the RT plan to the treatment console, but we send it to a location that's accessible by LinacView. So it's got a folder full of RT plans, and then when your treatment is running, for every beam of every treatment, you're creating log files, and those log files will actually go into a companion folder called a log file batch folder. So we have an RT plan batch folder, log file batch folder, and as log files come in, the system automatically matches log files to RT plans and does an analysis. So that's basically how things work. This is one possible topology. You can have a therapist at a console watching the treatments, and then basically, I'll show you how that works in the demo coming up shortly. And then you can also have kind of a post-treatment analysis. You might consider doing this as an additional value add for your weekly chart checks as a physicist, so you can go through actually and see what happened for all your patients in terms of fine detail of treatment delivery. Okay, here's the demo I had mentioned, and what I'm going to do is I'm going to start up LinacView. Here we go. So what I'm going to do first is I'm going to log in as if I were a therapist. And as a therapist, there are a lot of things about the analysis that the therapist might not be especially interested in. I should point out that this pop-up dialog that came up is essentially telling me I'm not connected to a bunch of different machines, which is not surprising because these machines are in a hospital in France, actually. But it shows you that one of the things that LinacView does is it makes sure it's doing those, keeping those connections, and it makes sure it does analysis on every fraction in real time. So I'm just going to close this. It may come up again. There's a certain time frame between it coming up. So here we have what we call the batch journal, and what we can do is actually simulate how a series of log files might come into the batch journal. So I'm going to just hit this button here, and what that's going to do is it's going to simulate the taking of the delivery of a plan or over a plan and the receipt of log files in that folder I showed you. So I'm going to just hit this, and you'll notice after a second or so that well, it says bank B not found. So what it's doing right now is it's actually importing. It's got the A banks, it's finding the B banks, it's doing an analysis, it's importing right there. You can see it. And what it's saying is that it's actually calculating a bunch of things. It's comparing RT plan control points against log file records. So if you have 180 control points and 3,000 records, which is not a strange number, you're going and doing all those checks in that short amount of time. Plus, you're doing a fluence to fluence calculation. So if you mouse over the window there, you can see we're checking things like fluence map comparison, rotation angles, beam on, beam off, things like that. These are things that are of a special interest to the therapist because they're really things that are patient-centric, things that got to be right for the patient to be treated properly. As a physicist, there are other things that we monitor that are equally of interest to you, but they're just not of immediate interest to somebody treating. So, for instance, exact leaf positions might not be that important. And it turns out that, and we all know this, that small errors in leaf positions and things like that don't dramatically change fluence maps. So here we go. One thing you can do here is you can the therapist can actually jump in and see to load a specific session. Okay, and I'll show you this as an admin in a second. So what you do is what you get is a summary of a bunch of different things. You get the carriages, the leaf positions, jaws, monitor units, fluence map comparisons, gantry angle, collimator, beam on, beam off, a lot of different things. And what you see here is essentially whenever it's green, it means it's good. And the tolerances here are in the last column for all of these. But I'll show more of this in detail when we go back to the our next step, which is showing you what a physicist might see. So I'm going to log out here. Okay. And I'm going to log in as a physicist. And what you'll see is you get a little bit more information. Okay, so immediately, well, maybe not immediately, but you get ability to back up the system. There's a very, very comprehensive system setup where you can set up different types of templates for your analysis with alert levels, error levels, certain tests you want to test or not. I can show you kind of what that area is. It's called analyzes sys thing, and you can. So right now I'm using the edited template. I think what I might do is now that's okay. There's user rights, really nicely set out. I, in using this program, have really only used intermediate and administrator, but you can see there's a lot of ways of setting that up. You can send emails, as I said, through the system. You can also have users specified, and this is where you're going to test kind of uniformly all these different parameters. But if you had several different Linux on your system, for instance, here you can choose who is going to get results from which Linac. And of course, I'm running as administrator here, kind of a demo, so I send all these messages to myself. So they end up wherever you want them to go by setting up these emails. If I wanted it to go to my Gmail account, I would put my Gmail account in there. Very easy. And let's see. That kind of gives you an idea. There's like, you can control like general parameters, like how long boxes show up, and control where the log files are. Lots of details here. A lot of that might be considered just system setup, so you really wouldn't have to be interested in that so much. What is important, though, is under the Analyzes section, where you can set up these templates. And what we do when we send you the system is we give you default templates which have suggestions, but according to your machine's behavior, you would probably want to modify those over a small amount of time. So I'm not going to save any changes. And what I'm going to do is I'm going to turn my batch on, which I didn't have to do in the therapist mode, but because there's so many things that you can do in administrative mode, that's what I'm going to do. So what I'm going to do is I'm going to load another set of plans, and what we're going to do is we're going to see what's going on here. So how interesting. So we're actually failing on something. What are we failing on? That's interesting. So on the left-hand side, the clinical parameter is passed. On the right-hand side, let's see, you're looking at a lot more things. And there's a lot of things that look here. I know from doing this demo before that we're looking at maximum leaf error position errors. And it might be noted that one of the things in Dynalog files is that there's a matching of control points to records or vice versa, and that's a little bit harder and a little bit less exact than in TrueBeams. So if I were to show you a TrueBeam file here, we probably wouldn't have any kind of leaf errors, but then that error is on the order of a little bit more than half a millimeter position. So you can imagine that really these leaves are coming in better than 2 millimeter. So that's one of the things that you would actually consider looking at in your clinic, and maybe making your errors a little bit larger so they wouldn't come up as failures. So, okay, so we just did that calculation. If I had some sort of warning or error on the clinical side, I would have had an email sent to me. Then that's all depending on how you set your thresholds. I'm using a template that doesn't find anything over there. So it shows you that you can customize that. Let's kind of show you how you have ability to load without going through this batch mode, RT plans, Dynalogs, trajectory logs, and then these 3 different types of Electa, ICOM VX, .dat, and XML logs. Now let's go directly to load right now. And what you'll see is the 2 patients that we just got through looking at. And the last one, we saw that there were some errors, and what we can do actually is select one of the, these look like, well, they are fractions, even though we did them all at the same time. We can load it in. And here we see everything's doing great, except that we have some maximum leaf error positioning things. And if you remember, I mentioned earlier that there's roughly a half millimeter error in with Dynalog files that just is very hard to get rid of. Let's take a look at what the leaves are doing. Here we see the RMS error, which is great. It's just fine. It's well below what you'd expect. And here we see some errors that are coming in 0.23. The maximum, of course, is 0.323. So If this were a template, the default template when you bought your system, what you'd want to do is say, you know, I'm going to set that error level at maybe 0.25, and that will account for some of these little tiny problems that there is with matching RT plan control points to the log file measurement records. You have basically a histogram of results. One really nice thing is that you can actually specify these little levels here, and the level says I don't want to have any more than 50% of my points. I want to have 50% or more of my points with errors less than 0.2 millimeters. And so you kind of get the idea. You can actually look at each leaf and what it's doing. If you're thinking, hey, leaf number 24 has a problem. Oh, it does. Look at that. You can see that. It has some problems at the beginning. Not really problems, but they're greater than the threshold. And you can kind of go through the leaves and see what's up, which is really cool. I mean, when have you ever had the opportunity to do that on this level of detail? Another thing you can do, I had mentioned pre-treatment QA. Here's that. Basically, here's a index. This is not this is a chi index, which this software supports gamma, chi, and something called a delta index. Most of us in this country are just interested in the gamma index, and that works just fine. But here you see a kind of a map, index map. On the right-hand side is an index histogram. You see that 99.7% of the leaf positions are within, or rather the doses are within tolerance. You get a side-by-side comparison of your RT plan fluence versus your log file fluence, and you get a subtractive display as well. And you might say, hey, this is pretty close to what I would do with my map check or my ARC check, and in fact the objective evidence is pretty much the same. So that shows you, if you are so inclined, you can buy the software to do your pre-treatment IMRT QA. Let's take a look at some of these other green tabs. Here's a small gantry error positioning in terms of fractions of a degree. And again, it has a similar kind of matching issue with the control points and records, but it's pretty what's the word, informative. Here we see that it's starting. There's probably an inertial issue with the gantry, and that there's some larger than average error going on there. You have similar displays for the collimator. Collimator errors, of course, it can be very, very small. There's a you can see when the beam, if the beam ever turns off when you don't think it should. That's really informative as well. And there's a dynamic view where you can. I'm going to turn off the right-hand display because it's actually something we're going to be removing in version 1.7. It's not as useful as you might think. And what I want to do is do an animation. And so you can see little tiny errors in placement, open too much, close too much. I think what we might end up doing is having a display very much like what's in PIPS Pro. I don't know if you've seen that, but it has it actually colors the leaves according to the error, which is kind of a nice display. On the bottom here, what you're seeing is leaf errors and gantry errors and gantry angles, and you're seeing MU delivery errors, and you're seeing, and of course they're all very, very small. And again, we can see the summary, which we saw before. Let's go back to load, and what we'll do is we're going to load everything, and let's see, do that. Okay. Okie dokie. So basically now what we're looking at is basically they're trends for this particular patient. We can under trends, we can look at carriages. I think the more interesting thing to look at is the leaf positions. Okay, so your maximum error is there. Let's see. this is really the more interesting maximum, which is the biggest value. And as you can see here, those errors are basically, the maximum errors are just, essentially around 2.5 or so. And remember what I had mentioned, that because of the matching, and if you can calculate out the essentially the worst case matching error, and the worst case is about 0.625 actually. And so right here we see we're at 2.5 rather in our error, and if we set it at something like 2.5, those you would only get situations where the leaf was out of position by something more significant than the maximum plus the uncertainty. What else here? I think that's a pretty good overview right now. Let me switch back and finish up this presentation. So what we've got is real-time log file monitoring for every patient with no impact on patient workflow. Really, the only things that are time-consuming, or well, not really time-consuming, when you send your RT plan from your treatment planning system to your R&B system, you also send it to the LinacView folder. That's done once. You would do that anyway, perhaps something similar to that if you're going to do pre-treatment QA with a map check. And then at the treatment console, you really have the option of having a therapist watching during real time, or if you don't have that, there's absolutely no impact on their workflow. And then at a later time, if you want to do it that way, you can have the physicist look at it perhaps during weekly chart checks. So it's a very low impact kind of system. And I know when I was working as a clinical physicist, if there was anything that impacted the workflow, it was really hard to sell it or hard to get it. And so I think this does not really impact workflow. It does add value, and as I had said before, essentially you're doing machine performance analysis for every fraction of every patient, and so it's easy to use, and I highly recommend you talking to your salesperson about purchasing it. And at this point, what I'll do is I'll open us up for questions, and let's see. Okay. So good. Let's see. Unfortunately, you can't talk to me, but you can chat with me, or you can send me some questions. And as I mentioned earlier, you can get CAMPEP credits for attending this session. You can get half a credit. We will also we'll send you the questions via your registration email, and also make available to you recording of this webinar. We do this with all of our webinars, and if there's other products that you're interested in seeing webinars about and you can't, for instance, hit a webinar time exactly on because of your busy schedule, you can actually request those webinars, and I believe they're on YouTube as well. So I guess I want to really thank you for joining me today, and I encourage you to consider buying this product from us at Standard Imaging. It's a great product, and it does things that add a lot of value to your clinic. Just the ability to track and trend every delivery for every patient, and having a record of that at a very high level of detail can be very reassuring to you and your administration and staff. Thanks a lot. I'm going to call this meeting to an end, and have a great day.